Hi everyone, and welcome to this week's AI Talks. Today we have Viman Deb with us that have a very long and interesting career in machine learning. Welcome, Viman.
Hi, thanks, Matthias.
How
Good
are
to
you
be here.
today?
Very good. Just getting started. I'm in Pacific time zone, so it's like kind of early morning for us.
Yeah. So you have a very interesting and quite long career in machine learning. I would love to know a bit, like, how did you get into AI from the start? Because you were very early there, and it was a very, say, different ecosystem at that point in time. So please tell us a little about it.
Sure, yeah. So I was working at LinkedIn in the year 2015. So I was working in the company pages team, which is responsible for all the company pages you see at LinkedIn. And at that point, the only process for creating a company page was for one of the company employees to go in, probably someone from their marketing team, to go in and create a company page, verify using their company email address, and then put in some mandatory data about the company. So it was a very long process with a lot of friction. So the coverage of company pages was not that great. And at the same time, LinkedIn was venturing into the ad space, and LinkedIn's ad targeting is actually like one of the most expensive and most high quality ad targeting because the pool of individuals you can target is really, really high quality. So one of the ways you target an employee is via their industry type. So if I'm trying to create a job and I want to target the software engineers, I want to know who are all the software engineers around there. Right. So at that point, the fact that LinkedIn didn't have enough company pages which were standardizing to employees at LinkedIn was causing a large gap in data which could be used for ads targeting. So we started with this project where we sourced a lot of company data from 60 different sources. Some of them were purchased, some of them were open data. And then we tried to create company pages out of them. And obviously, like one of the big problems is that there was a lot of redundancy because each of the 60 sources would have a bunch of companies which are repeated in them, right? And then some of them would have different taxonomies, so they wouldn't like combine together really well. So that's where I think the first time we started to explore clustering algorithm, and we didn't typically do like unsupervised clustering, but more like using a random forest model to decide between two entities whether they're the same or not. They consist a lot of like string-based features mostly, and that was the era where deep learning hadn't made its ascent. So we basically built a tree-based model, an ensemble of random forest, and then it performed moderately well. We did get like some of our crowdsourcing tools to create training data for us. And then after all of that, it performed pretty well. Like we increased the company pages from organically created company pages, which was at 3.6 million at that point to a total of 20 million. And that resulted in like many tens of millions of LinkedIn members being standardized to those companies eventually, and thereby creating or extending the ad pool significantly. So it was a pretty successful project. And that's the first time I really like got a direct feel of how powerful AI and ML can be, because there's no other way to solve this problem, right? You have basically like 60 different sources contributing gigabytes of data at that point. I mean, now we don't talk underneath terabytes, but it was still a large amount of data, and there was no way you could basically write, a manual algorithm to go through that data and combine companies together. So it was a really, really powerful way, and I really felt for the first time like how critical it could be. And given that we are good from that point, we were going to collect more and more data. The size of data storage keeps getting bigger, the cost keeps getting cheaper. This was going to be the natural evolution of how tech is going to proceed.
That's a very interesting journey, and as I can see on your LinkedIn, you continued and worked for Uber for quite long after that. Did you do any machine learning there also, or was it other types of development?
Yeah. So I was part of Uber AI. which is basically Uber's a global organization for machine learning. Uber does have very specific organizations within each teams as well, like Marketplace had its own AI and ML team, but they usually consult with Uber AI. The team which I was part of was Uber AI platform, which is also called Michelangelo. And specifically, I work on the Uber Eats home feed ranking model. So if you open up the Uber Eats app, you see a bunch of stores. Those stores are recommendations which are coming from the Uber Eats home feed ranking model. So that's what I worked on, I think, pretty much for majority of my time at Uber.
Would you like to tell a little bit, like, did you work with any specific technologies there in AI?
Sure, yes. So typically how a recommendation system is structured is you usually have like a large number of candidates which you want to basically find a set of relevant candidates from them corresponding to a query, right? So in case of Uber Eats, the query is implicit, which is basically your location and your taste, which is derived from your previous orders and stuff like that. In case of some other like search systems like Google search, the query is very explicit, where you basically specify the query you are trying to look for, right? And this query would basically then potentially have a lot of candidates to mine from, and it will mine certain number of candidates which are most relevant to this query. And then you basically will return those candidates to a re-ranker, which is typically called the second pass ranker or the or the third pass ranker. The first set of candidate generation being the first pass ranker, and then that ranker is basically going to re-rank these as per more context and more personalized ways for the user, right? And then sometimes there's also a blender, like I think in case of Facebook feed, you want to combine that with different kind of items, like you want some videos, some pictures, some text items. So each of them, it's sometimes hard to just combine them into a single model. So they have their own individual models, and then you basically calibrate the probabilities across those models and then fuse them into a one single list, enforcing some level of diversity that you don't want all your first 10 items to be feed to be videos, or first 10 items to be images, and so on and so forth. So in case of Uber Eats home feed ranking, we basically have these ton of stores which you can order from, typically in hundreds, or in some cases in thousands if you live in a downtown or very populated area like San Francisco or New York. So when you issue a query, we basically have this search infrastructure where we store all these candidate restaurants, and then based on that query, we want to find the most eligible restaurants to be returned to the second pass ranker, which is going to re-rank and return them based on more context. So I specifically worked on the part which was basically trying to source candidates corresponding to a query. A fairly popular strategy which is implemented for that is called a two-tower model. A two-tower model is basically a deep learning neural network where you have basically two different multi-layer perceptrons. And each of those perceptrons are responsible individually for, one of them is responsible for learning the query embeddings, and the other one is responsible for learning the item embeddings, which is basically in our case, the stores. And the query is information about the user, their location, their taste preferences, etc., etc. So each of these tower is going to basically learn an embedding. So embedding is basically a latent representation for an entity. So if you have a user embedding, that basically kind of denotes user sentiment, user's properties, or how user interacts with the system. So in the two-tower model, you can basically compute embeddings for both the candidate and the items. And the dot product of those embeddings is basically going to give you a score, which is going to be indicative of whether the user is likely to order from this restaurant or not. So we store the store embeddings inside the search infra with every candidate, and then we have a query which is converted into a query embedding. And then this dot product operation is a really, really low cost operation. So you don't have to typically learn forward pass for a multi-layer perceptron. And therefore, this is very powerful because you can actually evaluate a large number of candidates and return them based on their score, right? So you're kind of encapsulating the power of deep learning into a really, really simple operation, which is a dot product operation between a vector of numbers. So that was pretty much like largely the architecture. Now, of course, there's like I did oversimplify it in some places. I think some of these components were very, very detailed, very comprehensive, and took many, many quarters to develop. So, and I think the key here always is the data, right? Like the more data you have, I think in case of Uber Eats, we do have a lot of data from eaters engaging with restaurants. So the more data you get, the more the more crisp and more accurate your algorithm is going to turn out to be, right? So the focus is always that, trying to find clean data, trying to find structured data, and then once you have that, there's a lot of good literature we can help you build a model there.
Super interesting, and thanks for the explanation of everything. And yes, it sounds very advanced, and I can imagine it was quite an engineering challenge. And then you decided to basically leave the big tech companies, and you became a founding engineer at Kumo AI. I would love to hear a little bit more about that journey. Like, first of all, what made you decide to go into more of a startup environment, and then a little bit what you're working with there today?
Sure, yeah. So I've never worked in a startup, so this was obviously like something which I have been wanting to try out for a very, very long time. And it's usually hard to find a team which is so like with startups, obviously it's a very high risk situation. So I was like for a very long time I was doing for a team which I could really trust. With maneuvering the startup, I think usually team is more important than the idea itself. So if you have good leadership, even if you need to pivot based on market sentiment or when you're trying to evaluate your product market fit strategy, if you have a good team, you can always find a way out, right? Versus like if you have individuals who are really like more hard coded towards going to a certain direction, it's always hard to be flexible and pivot around, right? So I think like Kumo.ai, the leadership team we have here is exactly the kind of team I was hoping to work with. So I think it was the right time, the right opportunity for me. And then I think also the mission of the company, right? Like trying to democratize AI and basically bring AI to everyone on the modern data stack, which is basically, I think we already know that there are many enterprises which have data in Snowflake, Databricks, and similar data lakes. And being able to do AI on top of that using a very simple declarative query-like language is extremely powerful because it's fairly straightforward and easy to become an analyst by learning SQL. So SQL is not a very difficult language to learn, right? And then if you're able to do AI and iterate on the model, not just build a very basic model, but build a state of the art model with like really, really advanced research being baked into it, then that's extremely powerful, right? So I think the mission and the team both aligned really, really well. I have been looking for a startup for a very long time, and then I think it came just at the right time. So everything was like the perfect fit. So that was basically the reason for transition.
I'm happy to hear that you are happy with the transition there, and that you're building exciting stuff. And yes, I must say it makes a lot of sense that model and target those ecosystem, because what we can see, they are eyeing quite much into AI also, and trying to figure out like how can we fit AI into our ecosystem. So definitely the right time and place. So for example, at LabLab we are focusing a lot right now around transformers technology, basically because it allows people to build pretty cool stuff in a very short time. It's of course quite different thing from training and building your own models. But have you worked anything or with transformers, or played around with any of the technologies from OpenAI or Cohere, for example?
Yeah, so I think like one of the so Kumo AI is basically based on building graphical neural networks, right? And then one of the massive benefits of building GNNs is we've had a lot of progress with transformers and attention in natural language processing models, right? So and they have been extremely beneficial. So in the tabular models where you're basically trying to join a bunch of tables, create denormalized training data. it's not been very straightforward to use attention, right? But the way GNNs work, they basically allow you to message pass across different nodes and different tables, and then you're trying to perform a convolution operation, which basically combines um, sentiments from these different tables, right? So you can basically, so we actually use attention as part of combining that message and then combining it into a convolution operation and then trying to learn whatever your loss function is trying to optimize for, right? So like some of those latest technologies like transformer, for example, we are able to incorporate that in even into a tabular problem, right? So yes, we do use it pretty extensively, and I think that's one of the biggest reason why GNNs are more successful on tabular data because they also kind of um, learn from the topology of the data. In addition to learning individual features from tables, they learn aggregations, they learn topology, and they message pass across different tables, and therefore we are able to like really learn from the structure of the entity relationship model as well. In addition to, of course, learning from features.
Yeah, we are in a truly exciting time in AI, I would say, with a lot of progression. Is there anything that you are extra excited over in the AI space right now? Some progression or some technology or some type of subset that you see that makes you excited?
I think the overall landscape has significantly changed. I do feel that something which we speak less about. I think we speak about a lot of research and transformers and attention and stuff, but I think like one big area which is going to keep becoming more and more relevant is machine learning infra. I think it has always been in the background for a very long time, but it's like a sleeping dragon, which is basically being able to enable all the like if you think about most of the advanced models, right, they just keep growing bigger and bigger in size, and we still make them available for training at a reasonable time, along with serving them in almost real-time latency in many cases, right? Like I think Google has pulled off a lot of like really, really large BERT kind of models, and Facebook did Robert model, which basically is more fine-tuned version of BERT, and they're really large-size models, right? And they are using them to serve real-time traffic, right? So I think that will continue to grow, and that is one area where I think like a lot of development will happen in addition to, of course, the research which happens with model architectures and so on and so forth.
Thank you for that answer. And what are you do you looking forward here? Like what is your main role at the current organization? Like what are you working with day to day there?
So I focus a lot on the data platform, which is basically responsible for ingesting the data from the customer's data lakes and then converting them to a taxonomy which our models can understand. And there's a lot of like different components there, trying to understand the data, trying to understand the semantics of different individual columns, and then making them ready for being used inside the GNN. Now, there's like obviously some proprietary secret sauce there, which I think I don't want to talk about right away until like all of this is more available in the public domain. But at a high level, basically the pre-processing of data before we fit into the model.
Thank you so much for that explanation and description. I think we trying to keep these talks pretty short and sweet. Do you have anything you would like to tell the viewers about? Anything they should check out, or something you want to promote?
Yeah, I think generally, I think there's been a kind of a mental blocker for a lot of people who want to learn AI, that it is basic, like you need to be a great statistician or a mathematician to do that. To some extent, it's true. Basically, if you really want to go into deep research on building newer architectures and more improved loss functions. But I think largely, if you have data and if you're trying to build models, I think the level of API abstractions have reached a point where you should be able to do that being a software engineer. So I would welcome everyone to, take some basic courses. I think Coursera, Andrew in course is a great course to get started on deep learning. And anyone who's interested, I would encourage them to, take some courses, try some Kaggle contests, build some models. And it is something which I felt that, so I don't have a PhD, I don't have a master's degree either, but I was able to learn large parts of AI and machine learning just by getting my hands dirty. So it's totally a path which is possible for masses. So I would encourage everyone who's interested, take a course, build a model, try it out, and it's definitely something you can learn incrementally.
Yes, definitely the ecosystem have really opened up and become a lot more user-friendly, especially if looking at using the API solutions. We see, I mean, when we do the hackathons, we see, everyone, everywhere from people owning startups at plus $100 million in AI to people with totally different domain knowledge. But what we often can see is that when you mix these people together, so you get both 1-2 people with deep technical expertise and 2-3 people with heavy domain knowledge within areas, good solutions often comes out from it. So yeah, truly exciting time and really accessible for the bigger mass.
Yes.
And I think around 2015 when you started there, it was a very different story to get anything.
Yeah, it was still early.
Yeah.
Yes.
So tremendous progression in the ecosystem. So yes, I want to thank you so much because for spending your time with us here and telling us a bit about your journey. Truly exciting and impressive one, and I can't wait to see and follow the journey with Kumo.
All right. Thank you so much, Matthias.
Thank you. Have a great day.
Thanks.
Or is it morning at your?
It's it's morning. Yeah.
Okay. So I wish you a great and fruitful day. Take care.
Thanks, Matthias. You too. Thanks. Bye.
Bye bye.